You can now contribute to DDR's efforts at bringing you the latest in aerospace and defense indigenous development by contributing through UPI. We really value all your contributions. Thank you for everyone who's contributed so far. You could also join the DDR community on YouTube right here by clicking on the join link in the description below. Don't forget to hit the subscribe button and the bell notification icon to be notified every time we post a new video.
So after we got the OR when we went last time, the operational requirement, and subsequently we worked out two different configurations. We have zeroed down onto the Delta Canard configuration. Delta configuration, which is... So
you finished the comparative studies?
We have finished the comparative studies, and then with the user we have finalized the Delta Canard as the configuration. So that is what we have as a configuration. So being a aircraft carrier-based aircraft, we need to see the compatibility of this aircraft on the carrier that we have, both the carriers, the INS Vikramaditya and INS Vikrant. So the Indian Navy has told this will be a replacement for the MiG-29K. So we have to see the critical things like how the aircraft fits into the lift of the ship, so that you can transfer between the hangar deck to the flight deck and then do a very complete logistic enabling of this in terms of maintenance and flying operations and all that. So that part of it has been done by, if you would have seen that model there, there's got a wing folding. So in an unfolded configuration, it is 11.2 meters. And then when it is folded, we do the folding and then it comes down to 7.6, and we still retain the station, the weapons on the station, so that it improves the efficiency of taking it to the hangar and then bringing it back to the flight deck. You don't have to load not all the weapons, the outboard station and the tip missile are still there. And with that, when we fold also, we can take the thing to the hangar deck and then back. So this is what it is. Then comes the important things like, you need to come and land onto the carrier with a certain engagement speed onto the wires that are fitted there. We have 3 wires, the arrestor wires. So when you come and engage onto that, there is a limiting speed which has been told. So that is, currently we have been told it should be less than 140 knots. Somewhere around 138 knots. 140. It should be less than that. In fact, they have told 138. So what we need to do is, we need to see that the aircraft, when it comes and engages, it should be well within the margins. So you have, when the aircraft comes with a higher mass, that is with certain weapons and bring back load will be higher. So your approach speed will be higher. So we need to see that it comes with that bring back capability.
Can you share what the bring back load should be approximately?
Yeah, we no. It is we have a mass that has been to be brought back. The aircraft with 17.5 tons have to come and land back on the carrier. Empty weight we are targeting at 13 tons.
Okay, so 4 tons of meaningful load should be...
see, what will happen is you will have fuel also. We need to have three bolters.
Okay.
So you come and attempt. It's a very tricky job. You come and then you make a first attempt, and then if you happen to miss it, then you can go around. So you should have fuel for that. And then you come back and then make the second attempt, and then you can make
the requirement is for 3 bolters?
3 bolters, and then after that you should have a diversionary thing to a field which is somewhere around, that is a specification given.
Okay.
Not too far off, but it should be able to go and land on the
that's a lot of fuel that it needs to have.
Has the Navy given any letter of intent or any sort of thing to say that these are the number of aircraft we require in the future?
Yes, currently they have given that it will be a replacement for the MiG-29K, which is 45 currently. But we are also looking at more possibilities.
What about a Catabar variant? I asked you this last time also.
Yeah.
Have you heard anything from them about a possible Catabar variant in future?
No, the third aircraft carrier which the Navy is looking forward to is supposed to be, from whatever we hear, will be a Catabar. But we need, as an aircraft house, the details of the catapult launch. Because see, unless we know what is the forces that the aircraft need to withstand to get launched, we will not be able to bring in those features into the aircraft. So those are things which we are awaiting. So once it is done, we will be able to convert this aircraft into a catobar aircraft with certain modification. It will take certain definite time and cost.
When the LCA Navy comes,
Yeah.
how will this fit into the current scheme of things, the number of aircraft and
No,
everything?
the LCA Navy currently, we have 3 aircraft. Actually, 2 of them are flying and the one trainer is due to fly shortly in a couple of months. So what has been the driving factor to come to a twin engine is the requirement that, the LCA Navy is not capable of doing the full range of operational requirements the Navy is currently looking at for the threat scenario which
The TEDBF is based on the 414G.
currently, yes.
Yes.
See,
So-
we have designed it with the engines that we had already bought for the Navy Mark II, which is a higher thrust engine.
The AMCA is supposed to have a higher thrust engine sometime in the future. Will you have to do any modifications if the Navy asks for that engine on the TEDBF, or have they actually thought about doing that?
See, as a overall concept, it will work out that currently, I can tell the current situation. We have the Air Force Mark II program, we have the AMCA program, and we have the TEDBF. All of them have the same engine. We have configured around the same engine. But for AMCA, there is one specific requirement which is coming, that you do a super cruise. You're aware that, without
Without
afterburner, it should do super.
Supersonic speeds, yeah.
So the modifications that the engine, whichever is going to be fitted in to the AMCA, that is going to come in, will be, maybe a slightly increased intake, the thing and all that. So that interface we will also adapt for the TEDBF and Air Force Mark II, so that you get in the commonality, and then you will have the same engines and more number of engines, return on investment, and as a country also we benefit in.
You're saying not just the TEDBF, the LCA Mark II might also in the future, if the Air Force
I
wants,
mean, the
get
thing
high
is,
thrust
like,
engine.
if it's the same engine, then it will be
Lesser
advantageous for
dependence-
us.
Lesser dependence on the Americans also.
I mean, it is.
If you can just give us a timelines of what you're expecting. For instance, you said the CCS approval is expected this year for the TEDBF, and what about the development, the trials? What are the timelines that you're looking at?
See, we are not. We are basing the timelines with respect to whenever we get the CCS sanction. So from the CCS sanction, we will be taking around 8 years' time to get the aircraft into an operational level thing on the carrier. And subsequently, the Indian Navy is planning to induct this aircraft into the carrier somewhere around 2032 timeline. So once we get the CCS sanction, we will be able to do a lot of execution in the program side in terms of procurement of raw materials and other things. A lot of other commitments.
Because a couple of years ago, Dr. Devare told me that the Navy is looking at 2032 induction to begin.
Yeah, that's
So you have another 10 years to go.
yes.
So if you get CCS this year or maybe next year, depends, then it will still be neck and neck without a lot of buffer in between.
Yeah, it would be. That's what is the challenge. We need to work on as program managers and engineers. We need to work on. So I think there is a whole new method of executing programs nowadays. Just as you see in these kind of expos, you see the private industries from the contribution in terms of aerospace and thing has really elevated their levels. So we have a environment. No, it is not competition. We would say that we can complement their expertise and their capabilities. I would say their capabilities rather than, and then bring in experience into them and jointly work together. See, otherwise, if it was only held within one closed thing where public sector or thing, so it was very kind of constrained how much you can. So suddenly if you see we are doing this program, that program and all, we need to look at possibilities of engagement with private industries. And the good part that I would again reiterate is that they are all living us up to the expectations in terms of capabilities they have gained. Lot of them.
So in terms of design, we already have radar absorbing structures and materials being developed for the AMCA program.
Yeah.
And given that it is a marinized environment, are you looking at surface coatings, etc. for your specific case?
One of the
Even though it carries loads externally.
Yeah, see, one of the thing is like, as you are saying, the radar absorbent material and all those paints and other things or whatever has been developed will to some extent be applied for the other aircraft programs also, because one of our aims is to reduce the RCS to whatever extent. So, but as you rightly brought out, the challenges on constant exposure to the marine environment is a factor that we will look into in good detail and then qualify it before applying it on that.
Are you aware of any program at NAL for this specifically, or?
I mean, see, NAL is another extended thing from our programs. So,
They might have. Okay.
it's going on.
What is the approximate cost of the project TEDBF?
No, would you, are you talking about the development thing?
Yeah, the whole development process.
See, currently we are looking at 4 aircraft to be, 4 prototype aircraft to meet the requirements and to get it qualified in the timelines that are required.
Which is in 8 years.
Which is in 8 years. Which is in 8 years from CCS sanction. That is how it is. So, we are looking at somewhere around the 14,000.
40,000. Okay.
So we are expecting a PDR very soon. When do you expect this to go to CDR stage so that you can start prototype building?
Yeah, the thing is, one of the things which we, as a organization, which we have matured to is we are able to quickly leverage our capabilities that we have. The PDR stage itself is quite a refined design, and then from moving on from PDR to CDR, we have already worked on the basic framework, and then we quickly add on to that, and then an year or 14 months to 15 months is what we are looking at. Yeah, it should be able to do that, because see, the thing is, at CDR we are looking at the end of CDR the clearance for metal cutting and progressing the physical activities. So at PDR itself, if we are with the user concurring on most of the design requirements with their original thing, we will be able to quickly leverage and then release the drawings. Or nowadays, if you are looking at the inputs that has to go to the shop floor for realizing it, even a 3D CAD model is sufficient. So these are things which we leverage as we move on from
the LCA program.
See, we don't probably have to make 11,000, 12,000 drawings, print it out on a black and white and then give it to the 3D model itself will be given, and then the shop floor or the inspection themselves will be able to, they have kind of raised their levels also. So a lot of unnecessary manpower which is being spent on making a drawing, then detailing it. All those things are changed to a 3D CAD model with all the details in that. Then for the manufacturing, then inspection, all that it is.
It also cuts down on time, isn't it?
That's a major advantage. So these are things which we are looking at how we can. No, initially we have these 3 LCA Navy prototypes currently, which are in flying mode. We have landed the first 2 prototypes and launched from the INS Vikramaditya. So now the 3rd prototype also is getting ready, and once this INS Vikrant is ready with the aviation facilities and it sets sail, we will find a convenient time when we can go, and because the Indian Navy also has to jointly work with us, and then so it will happen soon. TEDBF will be happening subsequently because it takes time. So once the aircraft prototype, then we do shore-based testing. Then we move on to the, afloat, testing afloat.
Learning is drawn from the NCA Navy program.
Absolutely. That's a big, it's a very clean staircase which leads us to the
So I asked this last time also, but is the Navy willing to fund another LCA Navy prototype or low-rate series production until 2032?
That is something which must be on their plans.
Yeah.
We do not have any definite information as yet. As yet, we don't have.
And if you can, what will you use the prototypes, Navy prototypes,
Huh.
for learning, which will go into the TEDBF?
See, what will happen is when we make a naval aircraft, you can just go and do a simple, normal level of testing and other things, and then qualify it for only normal operations. But when you make a first-time aircraft, you have to do lot of variations. What we call as off-nominal conditions. So you have to face a lot of uncertainties out there in the sea when the ship is sailing, because it is, as it sails through, it will encounter different sea conditions, and this aircraft has to go and land on that ship, which is going through all these
It will
various.
give you data for refined design.
Yes, so what we do is, ashore, we do off-nominal conditions. We come with different roll, with different pitch up, different weights, and then we prepare this aircraft for all sorts of things. And then we take feedback from this and then put it back into our TEDBF aircraft and then make it a more complete aircraft for operations. It's not just a demo just to go and land and take off. So we need to see that this product delivers operational requirements.
And one more question is, this is brought up by one of your LCA Navy test pilots, Commodore Malak. So the underbelly hard points, which were, you said that they were going to be semi-recessed. Why are there only 3 and not 4?
So what will happen is, if you can do a semi kind of burial into the thing, then it will reduce the drag on the aircraft.
Correct.
See, now you have it's a naval aircraft.
Correct.
You have a landing gear with a very long thing.
Like
It's a bigger thing. So the stowage required is quite high. So you will require a very long volume.
Okay.
A very big volume for the landing gear bay.
Okay.
So what we can put onto the side it should not come in the way of the doors and other things.
Okay.
So if you put 2 in tandem on each side, you can make it 4.
Okay.
But what will happen is, I'll have to make another variant of that BVR, which will be shorter and which will reduce its effectiveness in terms of range and other things. So instead of that, we decided that we will have 2 on this under the wing and 2 under the fuselage, semi-burial, and that is sufficient for a operational clean configuration.
Okay. Because
For the Navy.
almost a like-to-like comparison is the South Korean fighter KF-21. They have 4 underbelly hard points, and they've moved out the larger storage to the underwing stations.
But are they a naval aircraft?
Yes, they are building one based on their Air Force version. We don't know how it will be, but that is their plan. At least their models show it.
But we need to see that. But do they have an aircraft carrier?
They're going to build one.
So, I mean, see, like this, we were like this in 2003,
Okay.
and then we started building a aircraft.
So you're saying they will learn.
So 2000, no, I'm just telling about our case. I'm not talking about them.
Got it.
But I am talking about our experience. 2003 we started, and then when we saw the aircraft carrier come in 2014, and then we learned a lot of things.
Okay.
So I would not comment on all this.
Okay, got it. And what is the store that is modeled here? Centerline hardpoint?
This is anti-ship missile.
Okay. Any specific variant?
It is a NASM MR which is being indigenously developed.